Alrighty, we are on day 2 of our 3 variable systems, looking at our second strategy, which is elimination. So we start with our 3 equations, 3 variables. What we're going to do for elimination is make a plan to determine which variable to eliminate. And we are going to have to do elimination twice to get down to our 2 variable system and then proceed from there. So on example 1, I've got, again, 2 equations, 1, 2, and 3. And what I want to do is look at if I combine 2 of these equations either as is or with a little bit of manipulation, can I get one of my variables to cancel? And looking at, as they're written, equations 1 and 2, my y's will cancel. So I'm going to combine equations 1 and 2. I don't need to multiply by anything to make this happen. And if I combine them, I'm going to get 2x plus 3z equals 5, and there is my equation A. So because I canceled y the first time, I now have to be able to cancel y again using a different combination of equations. So that could be 2 and 3 or 1 and 3. Again, looking at what I've got, 1 and 3, my y's will cancel without me having to do additional work. So I am going to combine those 2 as they're already written. And I'm going to get 2x plus 4z equals 0. And there is my equation B. So whatever variable you cancel the first time, you have to be able to cancel again. Now I've got equations A and B, and you can do substitution or elimination. I'm going to do elimination because my x's, I've got 2x and 2x. So if I multiply equation A by -1, I'll get -2x minus 3z equals -5. My x's will cancel, and I get that z equals -5. Now that I have found my first variable, the next one I can solve for is x, and I can do that by plugging -5 into equation A, equation B, or the one that we rewrote. I'm just going to go with equation B. 2x plus 4 times -5 equals 0. So 2x equals 20, which means x is 10. Now I need to find y. I'm going to have to plug x and z into one of my original 3 equations. Again, which one you do is up to you. I'm going to go with equation 1 because there's no multiplication involved in that. So that is going to be 10 plus whatever y is, minus 5 equals 4. 10 minus 5 is 5. And y is -1. So my solution for this system is 10, -1, -5. Okay, let's do another one. On example 2, I've got 3 equations, 1, 2, and 3. I want to start looking, can I cancel one of my variables without having to do too much work? Well, if I add equations 1 and 2 as they are written, my z's will cancel. So I am going to start with that. And I'm going to get that 18x plus y equals 10. There's equation A. Now, because I canceled z, I need to be able to cancel z again. And if I'm looking at my equations, if I combine 1 and 3, my z's will cancel again without me having to do any multiplication. So 10x minus 2y minus 5z equals 0. Minus 9x plus y plus 5z equals -10. So x minus y equals -10. Now that I have equation B, sorry if you didn't see that. Now here's your equation B. Now, again, substitution, elimination. If I leave these as they're written, my y's will cancel. Ooh, there goes my document camera. So x minus y equals -10. I'm just going to add these 2 equations as they're written. 19x equals 0, which means x is 0. I'm going to plug that into equation B. You could plug it into A. It's up to you. 0 minus y equals negative 10. So y is positive 10. And then I need to find z. Again, you can plug it into any of your first 3 equations that you started with. I'm going to go with the bottom one because I only have to do multiplication twice there. So that's going to be negative 9 times 0 plus 10 plus 5z equals negative 10. This is, of course, 0. And I get that 5z equals negative 20, which means z is negative 4. So my solution for this system is 0, 10, negative 4. And that is how you use elimination to solve 3-variable systems.